Hello class, well, welcome back to this interesting channel. If you've not subscribed, please try and subscribe so that you eventually have access to our interesting content. Today the question says what? Y is equals to sine, you see, not sine, sine k, sine inverse of x, and they say also what? Show that 1 minus x squared y prime prime minus xy prime minus k square y is equals to 0. This question is somehow critical. This y prime prime, it means double integral. You see it? It means what? Double integral. It means d square y all over what? Dx square. You see? Y prime prime, it means what? D square y all over what? Dx square. And also y prime, it means what? Dy by what? By dx. So let's solve it together. But it's a proof. They said if this is this, show that this is this. So let's pick the main question, which is what? Y is equals to what? Sine k sine inverse of x. You get it? So the best way to do is to use implicit function using implicit function. You get it? So I'm going to differentiate this, since we are going to, if you look at it, there is a first differential and a second differential. So we are going to be solving this based on trying to arrive at our answer, which is the showing itself. So differential of y, it means y prime. So the differential of sine, you get it, is going to give us what? Cos k sine inverse of x times what? The differential of what is inside. Let's assume if here is the angle, let's say it's going to be what? D dx of what? K sine inverse of x. You get it? And it's going to be what? Y prime is going to be what? Cos k sine inverse of x. So the differential of k is a constant. Let's bring it out. So the differential of sine inverse of x is going to be what? 1 all over what? Square root of 1 minus x square. Whatever it's here, we are going to take the square of it. You get it? So this is going to be the differential of this. So in that case, since we have a denominator, we can see over 1 here, and let's cross multiply. You get it? So by cross multiplying, we have y prime square root of 1 minus x square is going to give us what? Cos k sine inverse of x, and this k can become here like this. So if you look at it, we now have y prime square root of 1 minus x squared is. So in that case, using the implicit function, just like we said, we are going to differentiate this using product law. And product law, it means we know is u dv dx plus what? V du dx. You get it? Keeping this, differentiating this, plus keeping this, then you differentiate this. If you are a student of calculus, you will know that. So in that case, I'm going to differentiate this. So I'm going to keep this. It's going to become what? 1 minus x squared dot. So the differential of this is going to give us what? A double integral plus, you get it? So I'm going to keep this, then I'm going to differentiate this. But before that, if I should keep this, y prime is going to be what? D dx. Let me change it. This is going to be 1 minus x squared, because this is equivalent to what? 1 over 2. You get it? Which is equal to k is a constant, so the differential of cosh is going to give me what? Sin again, which is what? K sine inverse of x dot what? D dx of what? What is inside, which is what? K sine inverse of x. You get it? So we now have y prime prime square root of 1 minus x squared plus y prime. So the differential of this, the power will come here, 1 over 2. Then we have 1 minus x squared. Half minus 1 is going to give us minus a half dot what? D dx of the inside. So by differentiating what is inside, we have what? 1 minus x squared. You get it? Which is equals to what? K sine inverse of x. So the differential of this, k will still come out, is going to give us 1 all over square root of 1 minus x squared. You get it? So in that case, here is going to be y prime prime square root of 1 minus x squared plus what? My y prime dot 1 over 2 1 minus x squared minus a half. So the differential of this is going to give us what? Dot 2x. You get it? Dot what? 2x. So the differential of 1 minus x squared is going to give us minus 2x. The differential of 1 is 0. So which is what? Which is equal to k. You see k and k, we have k squared sine k sine inverse everything all over what? Square root of 1 minus x squared. So let's progress. So in that case, as you can see, now we are going to have y prime prime square root of 1 minus x squared plus, you see this 2 here will cancel these 2, so we are left with what? Minus x y prime, and this 1 minus x squared is, we can take the reciprocal and it will come down, so we have 1 minus x squared everything to the power of half. You get it? Is equals to what? K square sine k sine inverse of x all over square root of 1 minus x squared. Here we have x also. So in that case, as you can see, let's try and okay, this also can become y prime prime square root of 1 minus x squared. Plus times minus is minus, we have x y prime. This, let's equivalent, it can be equivalent to 1 minus x squared, which is equals to what? K square or sine k sine inverse of x all over what? Square root of 1 minus x squared. So if you look at it, let's try and multiply both sides by what? The square root of what? Let's say multiply 2 by square root of 1 minus x squared. And don't forget, our main target is to prove this, you see, and in our proving there is no any denominator, you get it. So in that case, when multiplying, we are going to have what? Y prime prime square root of 1 minus x squared dot square root of 1 minus x squared minus xy prime square root of 1 minus x squared all over square root of 1 minus x squared, which is going to be equal to my k square sine k sine inverse of x times square root of 1 minus x squared all over square root of 1 minus x squared. So you see, this and this will go, this and this will go, so we are left with what? So the square root of this and the square root of this, they will what? Because it's going to be what? Y prime prime 1 minus x squared, this to the power of 2 dot 1 minus x squared, this to the power of 2, you get it, minus x y prime is equals to k square sine k sine inverse of x, you get it. So in that case, so if you take the LCM of this, is going to be what? Y prime prime 1 minus x squared a half plus a half minus xy prime. So, and we know that sine of k sine inverse of x is equals to y. From the question, you see it, sine of what? K sine inverse of x is equals to y. So if we equate it here, so everything here becomes y, so we have y. So in that case, so half plus half is going to give us 1, so y prime prime 1 minus x squared minus xy prime, this is positive, if it comes here we have minus k square y is equals to 0. So we've proved what they say we should do. So if you look at it, so we have if y is this, they say we should what? They said we should show that y is equals to 1 minus x square y prime prime, which is this, minus xy prime minus k square y is equals to 0. So we have proved what they say we should do.